Hello, everyone. Welcome to the YT Lab of Everything. Today, we will discuss the third chapter of your NCERT science textbook, Atoms and Molecules. Ancient philosophers and tiny particles. Ancient Indian philosophers. Maharishi Kanad. Once upon a time, in a place called India, there lived a very wise man named Maharishi Kanad. He was curious about everything around him. He loved to think and ask questions like, what is the smallest thing that makes up everything we see? He imagined that if you kept cutting something into smaller and smaller pieces, you'd eventually get to a piece that was so tiny, you couldn't cut it anymore. He called this tiniest piece Parmanu. Ancient Greek philosophers, Democritus and Leucippus. Far away in Greece, there were two other wise men named Democritus and Leucippus. They also loved to think about what everything was made of. They thought that if you kept breaking something into smaller pieces, you would eventually get to pieces that were so small you couldn't break them anymore. They called these pieces atoms, which means uncuttable. So just like Maharishi Kanad's Parmanu, these atoms were the tiniest building blocks of everything around us. All right, let's break down the laws of chemical combination. Law of conservation of mass. What is it? Imagine you have a box of Lego blocks. You start building a spaceship with those blocks. When you're done, the spaceship is built, but the number of Lego blocks you used is the same as what you started with. You didn't magically get more blocks or lose any blocks. In science terms, the law of conservation of mass says that when you do something to matter, like a chemical reaction, the total amount, mass, of the stuff stays the same. You might change its shape or make new things, but you don't get more or less mass. Mass is neither created nor destroyed. Law of constant proportions. What is it? Think of making lemonade. Every time you make lemonade, you always use the same amount of ingredients. 1 cup of lemon juice, 2 cups of water, and 1 cup of sugar. No matter where you make it or how many times you make it, you always use these amounts to get the same delicious lemonade. In science terms, the law of constant proportions says that a chemical compound always contains the same elements in the exact same proportions by mass, no matter where it comes from or how it was made. Let's talk about atoms in a way that's easy to understand. What are atoms? Think of building blocks. Imagine you have a big box of tiny Lego bricks. You can use these bricks to build all sorts of things: houses, cars, robots, and more. Atoms are like those tiny Lego bricks, but instead of building toys, they build everything around us. In science terms, atoms are the basic building blocks of matter. Everything in the world, including you, me, plants, animals, and even the air we breathe, is made up of atoms. Parts of an atom. An atom is made up of 3 main parts, kind of like how a Lego figure might have a head, body, and legs. Protons. These are like the center or core of the atom, called the nucleus. Protons have a positive charge. Neutrons. These are also in the nucleus with the protons. Neutrons don't have a charge, they are neutral. Electrons. These are like tiny, speedy bees buzzing around the nucleus. Electrons have a negative charge and move around the nucleus in areas called electron shells. Why atoms are important? Atoms are important because they make up everything we see and touch. Just like how different Lego bricks can be combined in different ways to create all sorts of models, different kinds of atoms can combine to form all kinds of materials. Example, water. Let's use water as an example again. A water molecule is made of 2 hydrogen atoms and 1 oxygen atom. When these atoms stick together in the right way, they form a molecule of water. Let's talk about atomic mass in a simple way. What is atomic mass? Think about weight. Imagine you have 2 toy blocks. One is very light and the other is heavy. Even though they might look the same size, they weigh different amounts. Atomic mass is like the weight of an atom. What makes up atomic mass? An atom is made up of protons, neutrons, and electrons, as we talked about before. But not all parts of the atom weigh the same. Protons and neutrons. These are the heavy parts of the atom. Most of the weight of an atom comes from these 2. Electrons, these are very, very light. They don't add much to the weight of the atom. How do we measure atomic mass? Atomic mass is measured by adding up the number of protons and neutrons in an atom because they are the heavy parts. Proton, bash, 1 unit of mass. Neutron, 1 unit of mass. Electron, almost 0 units of mass because they are so light. Example, carbon atom. Let's look at a carbon atom. A typical carbon atom has 6 protons and 6 neutrons. To find the atomic mass, we add the protons and neutrons together. So, 6 protons plus 6 neutrons. 12 units of atomic mass. Why atomic mass is important. Atomic mass helps scientists understand how heavy different atoms are. This is important for identifying elements. Each element, like hydrogen, carbon, oxygen, has a different atomic mass. Chemical reactions. Knowing the mass helps scientists predict how different atoms will react with each other. Let's talk about molecules in a simple way. What is a molecule? Imagine a team. Think of a molecule like a team of friends holding hands. Each friend is an atom. When these friends hold hands, they form a group, which we call a molecule. Atoms coming together. Atoms. These are the smallest building blocks of everything around us, like tiny Lego pieces. Molecules. When 2 or more atoms stick together, they form a molecule. It's like when 2 or more Lego pieces snap together to build something bigger. Examples of molecules. Water, H2O, made of 2 hydrogen atoms and 1 oxygen atom. When these 3 atoms join hands, they form a water molecule. Oxygen, O2, made of 2 oxygen atoms. These 2 oxygen atoms hold hands to form an oxygen molecule, which we breathe in. Why molecules are important. Building blocks. Molecules are the building blocks for all the stuff we see, touch, and even breathe. Different properties. The way atoms join together can make molecules with different properties, like water being liquid and oxygen being a gas. How molecules form. Atoms form molecules by sharing or swapping parts called electrons, which are tiny particles that move around the atom. This sharing or swapping creates a bond that holds the atoms together. Summary. Molecule, a group of 2 or more atoms joined together. Atoms, the smallest parts of matter that join to form molecules. Examples: water, H2O, and oxygen, O2. Importance. Molecules make up everything around us and have different properties based on how the atoms are arranged. So, just like friends can hold hands to form a circle, atoms can join together to form molecules, which are the basic units of all the things we see and use every day. Molecules of elements. Imagine a club. Think of a molecule of an element like a club, where all the members are the same. Each member is an atom, and when they join together, they form a molecule of that element. Atoms and elements. Atoms, the smallest pieces of an element like individual puzzle pieces. Element, a substance made entirely of one kind of atom. For example, all the atoms in a gold bar are gold atoms, molecules of the same element. Sometimes atoms of the same element join together to form a molecule. Here are a few examples. Oxygen, O2, made of 2 oxygen atoms. These 2 oxygen atoms join together to form an oxygen molecule, which we need to breathe. Nitrogen, N2, made of 2 nitrogen atoms. These nitrogen atoms stick together to form a nitrogen molecule, which is a big part of the air. Hydrogen, H2, made of 2 hydrogen atoms. These hydrogen atoms join hands to form a hydrogen molecule. Why do they join? Atoms of the same element join to become more stable. It's like how friends might hold hands to feel safer crossing the street. How they join. Atoms can share parts called electrons to form a strong bond, holding them together. This bond creates the molecule. Molecules of compounds. Imagine a party. Think of a molecule of a compound like a party where different kinds of friends come together. Each friend represents an atom from a different element, and when they all come together, they form a molecule of a compound. Atoms from different elements. Atoms, the tiny building blocks of everything. Elements, different types of atoms. For example, hydrogen, oxygen, carbon, etc. Bringing elements together. Sometimes atoms from different elements join together to form a compound. Here are a few examples. Water, H2O, made of 2 hydrogen atoms and 1 oxygen atom. These atoms join together to form a water molecule. Carbon dioxide, CO2, made of 1 carbon atom and 2 oxygen atoms. These atoms come together to form a carbon dioxide molecule. Salt, NaCl, made of 1 sodium atom and 1 chlorine atom. These atoms combine to form a salt molecule. Why do they join? Atoms from different elements join to create new substances with different properties. It's like different ingredients coming together to make a delicious dish. How they join. Atoms in compounds form bonds by sharing or swapping electrons. This bond holds the atoms together to form the molecule. We will continue this chapter in part 2. Stay tuned for more videos like this. Don't forget to like, share, and subscribe to the YT Lab of Everything.